Hello folks, today we are looking at transformers, and in fact a transformer is basically a device that is used to increase or decrease alternating voltage. So we say a transformer is used to step up or step down an alternating voltage. A transformer basically is composed of two parts, a primary coil and a secondary coil. The primary coil is usually connected to a source of an alternating voltage. It uses current in a primary coil that also induces a magnetic flux, and this magnetic flux would cause an induction of voltage in the secondary coil. And so as far as transformers are concerned, basically they will either be used to step up a voltage. That is, when we say step up, we say we are increasing the voltage. When we say step down, we are decreasing the voltage. So basically a transformer could be used to increase a voltage or decrease a voltage, alright, depending on the number of turns on the secondary coil. Should we have a transformer that has greater number of turns on the secondary coil, then we say that transformer is a step-up transformer. That transformer will definitely be used to increase the voltage. However, should we have the number of turns on the secondary coil being less than the number of turns on the primary coil, then we say that transformer is a step-down transformer. It means that transformer will possibly be used to reduce an alternating voltage. Well, and we need to familiarize ourselves with some of the basic terminologies with regards to transformers. VP, which represent the voltage at the primary coil, IP, current at the primary coil, and P, the number of turns at the primary, coil. Let's consider, the secondary coil. We also have VS as the voltage on the secondary coil, and S are the number of turns on the secondary coil. IS is the current at the secondary coil. Now, so it means that transformers are used to step up or step down a voltage, isn't it? So stepping down means you are decreasing the voltage, and stepping up means you are increasing the voltage. How are you able to find out if a transformer is a step up or a step down? You consider the number of turns on a secondary coil. Should it be greater than the number of turns on the primary coil, then it is considered as a step up transformer. It is considered being used to increase a voltage. Should you have the number of turns on the secondary coil being less than the number of turns on the primary coil, then we say it will be used to decrease a voltage. Alright. So transformers should we increase the number of turns on a coil, will end up increasing the voltage. Should we decreasing the number of turns, will end up decreasing the voltage. So we can say that the number of turns is directly proportional to the voltage. Alright. Now, so it means that we can possibly write down this relationship. So under transformers, the equation that we can write is that should we take the number of turns on a secondary coil and divide it by the number of turns on the primary coil, it should be equal to the voltage on the secondary coil divided by the voltage on the primary coil. So this will give us our first equation under transformers. Second, the second equation we can write is that anytime that we increase the number of turns, of course I've said it already, we would increase the voltage, but we would end up decreasing the current. Increasing number of turns will increase voltage, but it will in turn decrease the current. So what can we write from that particular idea? So it means that if we take the current on a primary coil and divide it by the current on the secondary coil, it should give us the voltage on the secondary coil divided by the voltage on a primary coil. So this will be our second equation under transformers. It means that anytime we increase the current, we would end up reducing the voltage, or anytime we increase the voltage, we would end up decreasing the current. So that is the idea. And then the last equation has got to do with the power across the coils of the the power across the coils of the transformer. Should the transformer be energy conservative, then it means that no energy will be lost, and so the power across the primary coil will be the same throughout the secondary coil. But we know that power, mathematically, power is equal to the voltage times current. You know this basic equation. So it means that power will be equal to voltage times current. But as I earlier said, should we have a transformer that is energy conservative, that means that the power output would have to be equal to the power that we input. And power output is always at the secondary coil. So power at the secondary coil is equal to the voltage at the secondary coil times the current at the secondary coil, which will be equal to the voltage at the primary coil times the current at the primary coil. So we can write this equation, or we can possibly write this equation: the voltage on the secondary coil divided by the voltage on the primary coil is equal to the current at the primary coil over current at the secondary coil. And that is what I was able to write down here. Alright, so these are the equations we'll be working with. Alright, so this will be our third equation. This equation is just like a different form of the second equation. So let's quickly make a recap of what we have studied today. So we said a transformer is a device that is used to step up or step down an alternating voltage. To step down a voltage means is to decrease the voltage. To step up a voltage is to increase the voltage. So a transformer is said to be stepped up if it is being used to increase a voltage. A transformer is said to be stepped down if it is being used to decrease a voltage. And we're able to establish the relationship between the number of turns and the voltage across the coils. And we see the number of turns on the coils is directly proportional to the voltage on the coil. So should we take the number of turns on a secondary coil and divide it by the number of turns on a primary coil, we should get the voltage on the secondary coil divided by the voltage on the primary coil, and that gives us our first equation. And then we said for a transformer that is energy conservative, that means that no energy will be lost, and for this reason power will be constant across the coils of the transformer. And so should we take the current at the primary coil and divide it by the current at the secondary coil, it should be equal to the voltage at the secondary coil over the voltage at the primary coil. But we know power is equal to the voltage times current. So this is what we need to just familiarize ourselves with under the concept of physics. So I would bring you some examples or some problems, of course, IGCSE Physics involving sample questions involving transformers, where we'll be able to apply these equations to solving problems under transformers. Thank you so much for being part of my lesson. Hello folks, in a previous lesson we looked at transformers. Today we have a problem that we need to visit transformers equation and solve this problem. Now the problem goes like, the voltage from an alternator is 500 volts and is fed into a step-up transformer. This tends to be fed into overhead cables with voltage 20,000 volts. The A, calculate the required turn ratio. B, calculate the number of turns of the secondary coil if the primary coil has 25 turns. C, if the power of the generator is 100 kilowatts, calculate the current fed into the cables. Now let's look at the solution to this problem. Taking a solution to a problem that we have as an example of transformers, we would realize that we would have to go back to our equation of transformers, where that says that the number of turns on a secondary coil over the number of turns on a primary coil is equal to the voltage on the secondary coil over the voltage on the primary coil, which is in turn equal to the current at the primary coil over the current at the secondary coil. Then what does the first equation, what does it imply? It implies that should we have a transformer and you tend to increase, if you have a transformer then you increase the number of turns, that means that we have increased the amount of voltage and we have rather decreased the current. You understand? Should you increase the number of turns, you have increased the voltage. Should you increase the voltage, you have reduced the current. So that's what the first equation is telling us. And then should a transformer be 100% efficient, then the power will be constant. So the power will be the same across the secondary coil and the primary coil. So it means that power output will be equal to power input, and power is equal to voltage times current. Alright, so let's go back to, so it means that we are okay with these equations for now. So let's go back to our question. Now the question one was asking us to calculate the required turn ratio. And of course, the required turn ratio, we'd have to use this formula. The number of turns on a secondary coil divided by the number of turns, over there. The number of turns on a secondary coil over the number of turns on a primary coil should be equal to the voltage on the secondary coil over the voltage on the primary coil, because voltage, on the secondary coil and the primary coil were given. So we'd have to just divide 20,000 by 500 and we'll get 40:1. So the number of turns, or the required turn ratio, is 40:1. All right. So it was quite easily done. Now the B part of the question was asking us to calculate the number of turns of the secondary coil if the primary coil has 25 turns. So they have given us that the number of turns on the primary coil is 25. So using the formula, the number of turns on the secondary coil over the number of turns on the primary coil, you would find an expression for the number of turns on the secondary coil, which will be equal to 40 times the number of turns on the primary coil. You get it? So using this formula, if you want to find the number of turns on a secondary coil, then it means that it's going to be the number of turns, the voltage, that's 40:1. That is, since we have the ratio, we just have to, equate it and multiply it by the number of turns on the primary coil. And we'll get the number of turns on the secondary coil to be 1,000 turns. All right. Now the problem is the last part of the question, which is asking us to, calculate the power generated. They gave us that the preamble that if the power of the generator is 100 kilowatts, calculate the current fed into the cables. Now we should note that in this question, the generator is the primary coil, and then the overhead cable is the secondary coil of the transformer. So it means that to calculate the current that has been fed into the cable means that we have to be calculating the current at the secondary coil. So we have to calculate the current at the primary coil, and then we establish the relationship and equate it to the the current at the secondary coil, and then we can proceed to do that. However, from the question, the data that was given is power. Power was given as 100 power 100 kilowatts, and 100 kilowatts is equal to 100,000 watts, because the standard units of measurement of power is watt. So we'd have to convert 100 kilowatt to watt, which will give us 100,000 watts. All right, but we know the formula for calculating for power. The power is equal to the voltage at the primary coil times the current at the primary coil. So we want the current at the primary coil. Current at the primary coil will be equal to the power divided by voltage at the primary coil, and this is going to give us the power. This is 100,000 watts being divided by the voltage at the primary. The voltage at the primary coil was given as 500 volts, so we can say 500 volts. When we do the division, you are going to get these cancel this, 5 goes here, 2, so 200 amps. You are going to get 200 amps as the current at the primary coil. But that is not what we are looking for. We are looking at the current at the secondary coil. So what we do now, the relationship between current at the primary coil and current at the secondary coil is that is the number of turns on the secondary coil over number of turns on a primary coil is equal to the current at the primary coil divided by the current at the secondary coil. But we have this ratio, NS over NP is 40:1. So 40 over 1 is equal to current at the primary over current at the secondary. But we are looking for current at the secondary. So we can say current at the secondary coil, that is the current fed into the cable, will be equal to current at the primary coil divided by 40 times 1. So the current at the secondary coil is equal to current at the primary coil, which was 200 amps divided by 40 times the 1. So should you cancel this one, you will get the current at the secondary coil to be 5 amps. So what can we say from it? We realize that, let's do some explanation. We realize that the number of turns, let's look at the number of turns on the secondary coil was 1000, and the number of turns on the primary coil was 25. So it means that this was a step up transformer. All right, so should you step up the transformer, you would increase the voltage and then you will reduce the current. Increasing voltage, you will reduce the current. So realize that since the number of turns on the secondary coil was 100,000, which was greater than the number of turns on the primary coil, which was 25, resulted in a lowered amount of current, 5 amps and 200 amps, because the current at the primary coil was 200 amps. So it needs to be stepped up so that the current will be reduced. It needs to be stepped up so that the voltage will be increased. So if you increase voltage, you are reducing current in terms of transformers. All right, so in a nutshell, you understand the whole concept. All right, so we would be solving more problems with regards to transformers. So thank you for joining me, and I'll see you in my next video. It's bye for now.